All right, welcome back to EuroForth. This is the last session for today, and I'm going to be presenting, what did I call my presentation? That's a good one. Calling C from forth automagically. Now, I've talked about how to call C from forth several times, but now I'm going to make a bit of a hands-on. It's more of a tutorial, of interactive one, okay? So, that being said, it's very interactive because you're now looking at the editor and the terminal. Oh, then please look up there instead.
No, I'm looking here.
Complaining about font sizes.
I think that's, well, you know, we have to do some typing there, so I can't. Can you read it okay?
I can read it okay here, yes.
Varifocals, which is the problem, I can't.
I mean,
I've got it now. That's the right angle for varifocals.
Got it? Okay, then I'm not going to change. Right, so in Edinburg, I hope the pronunciation is not completely off, I was having some good talks with all of you and with Chuck back at the time, and it just was a lightning strike into my head, explaining to me how I could make the whole interface a lot easier. And now this actually kind of works. Okay, it's not completely finished. It's not going to be shipped tomorrow, but it is very close to being actually usable. So all that I'm showing to you today is what I call the C warp gate, because the old one has no name. It was just the C interface, so to distinguish the two. The new one is the warp gate. The old one is just the C interface. And most of the stuff I show you today is true for both. So if you want, you can just go ahead. Now, all of us are writing their the C functions they want to call in some form or the other. VFX has their the external interface, the internal external interface. GeForce has an interface where they actually compile a little wrapper for it. And I think SwiftForce has a very barren interface, but come again?
Function call.
Function call, but I think you have to do the parameters yourself or something on that one, right? Yeah. So I'm just saying that there's different approaches depending on what you want to do. And this is taking it all away. So the future is just 3 steps. We generate something that's called an interface file. They end with an I. And we're going to start with OpenGL, which is called GL for short. It's the graphic language. And then we run swig warpgate to create something that's called an FSI file, which is the forth script independent. That means that it can be run on multiple machines and architectures. And then we compile that into a shared object or DLL, and then we load that by forth. So it's only 3 steps anymore. And the beauty about the whole interface is all functions have the same signature, the same parameters. You just pass a structure with your data stack pointer and your floating stack pointer, and you return the same structure. So you only have to implement 1 call per architecture, per operating system, of course. So I thought we really start with 0, so to prove that we can do that, and it's not very hard, so we do gl.i, okay? And now we say, we set it's a swig, okay, %module. So the first thing we do is we say, what do we want to call our module? All right? The stuff we are creating now. The second thing we say is we want to include gl/gl.h. And now we are done. Because everybody always keeps telling me how hard it is to write interface files. I don't think that's very hard. You put the name of the header here. However, I'm lying. There is one extra step we need to take. I'm going to explain it in a moment. And hold on, I need to look at my cheat sheet for that, so that's not a good sign. But I'm tired, so I have an excuse, hopefully. And where did I put it? Oh, here it is, of course. Yes. Oh, yeah. It's the %insert, include, and it becomes very obvious in a moment what this does. And here we are using hashbang, or what do you want me to call £sign these days?
It's a hash sign.
It's a hash sign, okay. So what are we doing here? Well, this is obvious, %include. We are telling, dear Swig, please go ahead and parse the whole file and generate something for us. And here we are saying something, and dear Swig, please insert into the include section this very header, because otherwise this FSI file will have no clue where to actually find the constants. Right. And now we're running this command. It looks a bit odd because I'm using it in a special environment, but let's go through it together. So I'm just calling Swig, it's just a fancy version of it. And now what language do we want? We want to have the force language, and we want to include user include. This is on Linux where the include files reside, in case you don't know. So maybe on Windows you want to have a different one there, okay? And now we do gl.I, and that's it. Now let's take a look at this newly generated file. Oh, yeah. Let's just pretend this is, yeah, I want to delete it for a moment. No, I forgot to set the output name, so gl-fsi.c. So now, but if we look now again, there it is. And now please have a look at the files together. And you can see here the standard includes. And here you can see what we just included before, right? If I was just writing right, it will then also just go exactly here. Okay, so it's just a plain macro inclusion, nothing fancy. And now you don't need to read all of this crap, so we're just going briefly over it. So yeah, let's skip that because this is all internal stuff, which is kind of magic. The capture card is acting up in a really weird way. Let me just see if I can fix that really quickly. Not sure if somebody of you have left and me. Yes, let's do it like that. Yes, that's why I fixed it. But it's not here physically, so everything works. Okay, so, well, here is this magical struct we actually pass. We give it a cell with the data stack pointer and a floating stack pointer. And this is called a pointer pair. And then we define functions to push and pop something off the stack, and to do the same of the floating point stack. Now that we've defined all of this stuff, let me just show you a really simple thing here. So for example, this call here, okay? So Swig export is just a macro because again, you can use it on the Linux, Windows, or Mac OS, and it depends on what you generate there. I think what you would gonna be, you can put there the DLL spec you would put there on Windows, for example. Right, and then you can see, again, it's always the same signature, right? It says Swig export, pointer pair, Swig std call, the wrap, and there's a pointer pair and returns the same pointer pair again. And it's the same for all these arguments. And in case of clear, we have a bit field, which we just pop, and then we pass to the function. And then we return nothing in that case, okay? Here we have a more complicated call, which does several calls. But you see what the magic here is? We don't need to do that. That's done all by Swig for us. So Swig knows how many arguments there are. It knows how to typecast all of this stuff, which we really don't know, or which we would have to look up, okay? So, now, are there any questions so far on this generated file? Again, you don't need to understand it. I just wanted to show you that there's no magic in it. And maybe we can find something which also pushes something. Yeah, here, for example, we have a call which is asking is enabled. So it takes an argument off the stack, which is an enum, like are color filters enabled? You would say GL color filters enabled, and then you say GL is enabled, and then you get the result pushed back on the stack. Yes, please. Double click. Yes?
So what is the difference from the stuff that we have been doing, or you especially have been doing for GeForce?
So with GeForce, instead of creating these calls here, we only create the C function blocks. So C minus, so GeForce would create for this Let me see if I can just do it by hand. A G-force, or let's say examples, and then let's put G-force here. Oh, where is it? Maybe let's start with VFX, because we would just say extern colon, and then we would say GL Boolean is enabled, and I think we would put an int there. So this is how it would maybe look like in VFX, although we are not very type smart, right? We have to go to the basic types, so there is some action involved. So, while as in, also another one for,
The next turn in there somewhere.
yeah, sure. This is approximately what it would look like in VFX. I think in SwiftForce it's something like function and only this here, right, Leon?
Yes.
And I think in
You need the stack parameter.
I do?
You do. That's how it.
Like one? Like here, or what do I do?
Space, part one, dash dash. Does it return something?
Like that? Or with parentheses around it?
With
It's a stack function. It's very forth-like.
Yeah, okay.
Does it return something?
Yeah,
So on the right side of the dash dash, you need what it returns.
nothing. Oh, it does. Sorry, int.
Sure, that's fine.
Okay, then with G-force, I think, but it's I don't know the exact notation now. It's a bit more complicated. I think it's something like GL is enabled because G-force allows you to actually rename the function. Okay, which I think is cool. And then you would down here you would have something like NN. Okay, this is approximately what G-force does.
Yes, that's the input syntax, and that GForth generates wrapper
Yeah.
functions.
Exactly. So GForce
And-
always needs GCC at runtime, or at least to have it precompiled somewhere, but normally it wants to do it at runtime. And this is just, depending on what systems you use, that's cumbersome, or it's easy. It depends. On Linux, it's not a problem, but on other systems it is. And also maybe you don't want, normally in productive environments, you don't allow compilers, so there are certain caveats. So with GForce, when you ship the software, you would, with the current system, you would also expect the shipped software to be able to compile C stuff and to have the C headers and all of this. Whereas the new stuff would not require that. Okay? So the new function would just be a DLL or the FSI file, which you can compile, but again, it's the same for all of our systems for all the time. Okay. So, any more questions to the FSI file? Right. So then in order to compile the FSI file, you want to do something like that. I'm just going to paste it right here. And it compiles without error. So now we're not going to run this very example, because what we just did is I now showed you how to compile GL, which is made to be portable and made to be run outside of C. It's made by smart people. Now we are getting more and more into bad design, okay? And what I would like to do next is SDL. Also with GL, I cannot show you something because, as Nick said before, stuff builds onto GL. So for example, I think the new GTK probably builds on Vulkan or on GL, but it always has a GL layer as well. But you would want to have GTK get you the window, and then you get the context for GL, and then you can render something, right? The same for, there's other systems. But again, I just wanted to show you how easy it could be. Let's make it more complicated. So let's make something SDL. And now I really need my cheat sheet, because otherwise I'm going to be wasting your time, which I don't want. Here it is. Okay, so SDL, I can actually, if all works, I can show you a window at the end, okay? But we shall go there together. So let's say we want to do SDL.I. We already know how to start. % module SDL2. Well, let's just pretend we're only doing SDL, yeah. Then we want to do this insert into include. And what we want to insert, of course, is include SDL2/SDL.h. And at the very bottom, we want to say include, oh, we just use this one here. I'm too lazy to type that. Then we say swig. Okay. Now, let's see what that does for us. Again, we are using swig, but this time we are saying we want to have SDL minus FSI and SDLI. And it's telling me, yeah, of course, that I made a boo-boo. Syntax error on line 144. Oh no, there's a syntax error inside the header file. Now a lot of people give up. Don't. Okay? Let's actually look what's happening there. And should I make a new one? No, I should not. I should just go here, /user, include, and then make a, yeah, go ahead. And then make another nerd tree, but lcd/user/include. Hello? Oh, come on. Okay, it doesn't want me. SDL2, and we go in here, and we were in SDL, right? And it said line 144. Oh, that's a decal spec. Now, what is a decal spec? Now, you should ask yourself, do you care? No, we don't. So we go right ahead, and I'm going to close the two GLs now to have some more space. I'm just going to say define decal spec with nothing. All right, that should do the trick, right? Oh, there's still an error. Let's take another look. Oh, extern, we know, decal spec we fixed, int. What's an SDL call? I don't know what an SDL call is. Let's just define it. That should do the trick. Yes, it did. That's it. So you see, there is some work involved in automating this. But what you actually did now is you made this work for all the future as well. So if there's an update, they are unlikely to change a lot. Sometimes, of course, major upgrades, you will have to put some more defines in here or change something. But I wanted to take away the fear of doing that. Now let's see what we actually compiled. All right, here's our include, so that's good. There's the same boilerplate we've seen before. And here's the functions we are using. Okay, now where is our interest? Oh, here it is. SDL init subsystem, quit subsystem, right. That looks good. Let's scroll down. What? 437 lines for a huge library? That does not sound right. Now let's take another look at the glfsi.c. That looks more like a proper library, doesn't it? So what went on there? So let's go back to this one here. So, okay, we can see here something has been defined in here. That's good. There's some stuff defined. Okay. But, oh, it's like GTK. It has some definition for everything. Now, you can instruct Swig to go down the rabbit hole and go into every include, but you never want to do that because you know how far the rabbit hole with C leads. We don't want to compile the whole system. So what we normally do is, and now we're going to cheat a bit, and I'm going to take from the prepared stuff, because again, I don't want to make you wait. We want these, okay? Because what I want to show you is a window. For a window, I need video. That's what they call it. I want to show you something in that window, so I need to render it, and we shall interface with the window, at least be able to close it, so the events. So these are the three we want in there. But again, this only includes them at the very top here. It does not do anything for us down there. So we shall just use these three, go down, and then our %. Okay, wonderful. I'm sure there will be no more surprises. Oh, he just told me that I should not worry about that. Okay, well, let's see what SDL events does. Okay. So /user include SDL2, SDL events. Right, there we are. And it's 669. And there you go. What is an SDL compile time assert? We don't care, do we? Because we are here to actually get this stuff running and not to do, we don't want to check anything. So let's just say SDL compile time assert. And this seems to be a macro with how many arguments? There is one. And because the font is so big, I cannot see the rest of it.
You've got at least 2.
Oh, you're seeing more on your screen. That's cheating. So my okay. Anyway, now it seems to, okay, now it wraps. So as Peter said, there's 2. Now we're going to name them very interestingly, X and Y. Okay, it gives me some warning, which you can ignore for now. And now you see we just compiled a whole lot more. So let's look at our FSI file now. Ah, much better, right? We want thousands of lines of not writing ourselves. We want to auto-generate them. Yes, okay. Yeah, forget about the main function. Actually, one function I want to show you while we're in here, because Leon asked, is the, I think it's called swig entry function. Oh, everything is named swig, Gerald, so maybe you, oops. Well, how did you call it? Would be smart to know. And I called it, oh, swig forth. Okay, that's smart. Slash swig slash forth underscore, yeah. Oh, it was just in front of me. Sorry for that. Anyway, this is the function the forth system itself calls. And guess what? It takes a pointer pair as an argument. And that's about it. So what it does, it generates a temporary file. It then has this function called swig unsigned int constant. It's nothing fancy. It's just essentially, it's making the code a bit more readable, because if you look up here, it just does fprintf with constant and name. So, but yeah, so we have all the constants. Then we have the integer constants. Then we have some more constants, of course, because this is a big C library. Yada, 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 yada. Come on, where are some functions for me? Okay, and here they are. And you can now see that there's a swig function called SDL init. So this is the name. This is the, because you can also, again, here you can also rename them. And this is the wrapper name. There's some structs which we don't have support yet. I really want to add that. And you can see, yeah, we really want to add them. And at the very bottom somewhere, it will go on with the other functions, as you see here. Okay. Is for everybody a clear understanding of what we just did? Very good. So now I shall switch over to the SDL folder, or whatever I called it. Oh, I called it SDL2 because it was the correct name to call it. And in here we have a make file, because nobody wants to do this stuff all by hand. Oh, let's just make clean and make, because we are brave. Yes, and here we go. You can now see what we've done before. It's the same stuff, right? We have the warning from it generating into the FSI. Then we are compiling the FSI. And at the very end, we are actually generating the wrapper. Now, let's use VFX to actually run that. VFX, I think it's called this, include, and what did I call it? Oh, I call it VFX load dot fifth. Right, there it is. And now what this did for us, it shows us all the functions here while it compiles them. And up here you can see the constants. There is a reason why there's not all constants, but I'm not going into this right now. The most important ones are here, okay? And I shall show you now the next thing we do, because SDL2 slash VFX run.fifth. So what we do next is, I don't want to type all of this. I mean, we can if you're feeling fancy, but essentially what we're doing, SDL init video, SDL init, and we're just putting the return code on the stack, we just print it. Then I set the window title to EF 2024 and actually create the window. I don't care where it gets created. I want it 600 by 400, which might be awfully small for this screen, but we don't care. And then we call SDL window. At the next stage, we are passing this very window and telling it to create an hardware accelerated renderer. Again, here's a magic number. It should not be here. It should be a constant. I was tired and lazy last night. So we then create the renderer, and at the very end, we actually want to get the surface. That's something we can render on. And then we have got a very advanced program, not so different from Nick's demo, actually. It has a global called game running. It sets the background color to green. And then we have this pump loop here. It doesn't quite fit on the screen. Maybe let me just delete some white space. So yeah, we don't need the draw command, for example. Yeah. It should work now, okay? So what we do here is we're pumping events with SDL poll. We're getting this event, and then it's very convenient. The very first integer of the struct event is actually the type of event. So if I quit, well, I want to get out of the loop. And if I press a key, I want to set it to blue. And if I release the key, I set it to red. Sorry for not including yellow. Otherwise, it would have been a perfect example of making just the same thing. And now I'm going to include VFX run.fifth. And here is my window. And if I press a key, it gets blue. If I release the key, it turns red. And I have not written a single extern call for that. That's what I want to emphasize here, right? All we really did is we wrote that stuff here, and we got all of SDL. Well, not all, but if you just follow my lead now, we have done 3 of them, and we took a look at SDL. It's like 20 or 30. So you're maybe going to be busy for an hour or 2 chasing through all the different warnings, but at the end you have a proper system. Okay, you can also actually see that the mouse is moving when I press a key. So it's already detecting all the keys properly. Now let me quit that. Okay, and now we're done with SDL. Are there any questions so far? Very good. Now, what would you like me to see to do next? Because it should be a bit interactive. We can now dip our toes into GTK4, which we will not be able to finish, and I will tell you why. But that's now a harder problem, of course. Or I can show you how we actually perform the call in VFX. Would you like to see how you actually do the call, or would you like to see? You would like to see the call, Leon? Right. So that's in this file, SDL2 and VFX load.fifth. Yes, I know I already have opened it. Right, forget, so there's just some stuff which is internal stuff, evaluate line. Here we are. This is the one call we need to define. Okay? So, that's the integer only call. Is that correct? I don't think so, but maybe it is. Anyway, I don't want to describe the assembler to you. I want to show you how little work it is actually. And this is just the operating system specific, architecture specific call you have to make. All else you can see down here is already high level code, and that's all of the code. So all of our systems only have to implement, for this whole thing to work, this one call here, and they have to implement something that's called warp-C, which approximately looks like this. Okay, so there's nothing fancy, but we already have it compiled into our kernel. And yeah, this is already some callback magic, but again, I told you yesterday about the trampoline, so callbacks, we're not doing that at the moment. And oh, here's actually the new version of warp-C. So warp-C is something that needs to be defined because that comes with the evaluate, and everything else is absolute standard force. And as you can see, for example, down here, I then have defined something called loadlib, which does nothing else but load a library, but loads it lazily. And then the open warp again, it does nothing special but to do just the loadlib we did before, and to execute the entry word and then compile the entry string we've seen before. Okay? And so you need to load the library yourself. I thought about automating that, but it is very operating system specific and very specific where the libraries are. And it is very easy for you to just find that out and just put it in yourself. It's more, I'm thinking of maybe suggesting it, like saying, I think it could be here, try that. And then if it's not, you can try to load it somewhere else. Okay? So this is how you call stuff. Any questions? Is it simple enough, you think? Okay. So again, the real magic here is that we actually pass the stack pointers instead of trying to do all the stuff ourselves. As Anton asked before in GeForce, the wrapper does it for us, but actually Bernd was the one who suggested this super simple interface of just having one and then later two items and just pass the stack. Because when we were having a very interesting fight, because I just said, I want to automate it. Well, if you want to automate it, I only give you the stack pointer and you do it yourself. And that was a very good recommendation, right? And then we also added the floating point stack pointer. There's that. Okay. Peter, you wanted to ask something, or you just raised your biro?
No.
Okay. Yes. No, still muted. Double click. Yeah. Now you do.
So now I understand the difference. So the answer to my previous question. So basically, what we do in GeForth is generate these wrappers from these C function thingies.
From this very definition.
Yeah, right.
Yeah.
And what you are doing is you generate it directly from the header files.
Right, but we also in GeForce we also generate these things here using the old Swig.
Yeah, we generate these from the
Yeah.
header files, and then from these we generate the wrapper,
Yeah.
and you do it directly in one step.
Yeah. So if I go back all the time, so for those of you who don't know, Anton is my professor, and I actually made my bachelor thesis about just that. And back then I was just presented, this is how the C interface works, please generate something for it. That's why it works like this, and all the other systems also did it like that. I've now gained sufficient knowledge to know how to do it better, or I think I do. And that's why it's now a full-blown interface, and it's now working differently. And that's actually the way Swig wants to be driven. I had to change a lot in Swig to not output C at the end. Okay, so it also has this C step, but making it output false at the end was a bit cumbersome, and now this is much smarter and much simpler.
How do we access a constant or a structure?
Right, so a constant, if we go back to the output, which is here, a constant does this very thing. So if we go down, here we have SDL hit test resize left. Okay, that's the constant. You can see there's no quotes around it. And then you have the string, the name of the constant next to it. And if we now go into this very function, we can see that it does an printf into our temporary file. And it uses this macro. And if we look at this macro, it does %ld, then a tab, constant, %s, new line. And this gets put into the evaluate buffer, which is executed upon entry of the DLL.
Okay, so what does it look like from the fourth side?
Like that. Oh, for the fourth side, it's this one here. That's the fourth side only does loadlib, then it gets the address of the function, then it gets, so that's the address of the function, right? Then it calls it manually, and I actually type it as well. Also, when we type it, we can actually see the fourth side at the very top. I mean, Let's just go there and find out. Yes, here it is. This is what we are actually, this is what we are reading into the evaluate, all of this. And this just gets evaluated then. And then down here,
Very clean.
yeah, there should be nothing special here, right? And it's also much smaller than the old interfaces with all the definitions because they're all gone. Now we only have names. Now, yeah. Yes, please?
So, yeah, one thing we have had over the years is dealing with types like of T or something like that, which may be double sized. So, can you demonstrate how you do that?
There is nothing really to show you here. I mean, yes, sure, we can. There's a file I call the basic library, which actually is a library which I then generate a wrapper for. So we can use that as an example. If I remember how to use it. Oh yeah, I have to go here, I think. And you want to do what?
Well, I want
No,
to.
just tell me the code.
What do you want?
I want of T to be a double cell integer on the fourth side.
Okay. I mean, you can. Let's just find out. So it's of T, right? And then we just call it get of T. And we say this is an external function, okay? Something like that?
I don't.
No, I mean, you want to access a function which does something like that. That's my question.
Yeah.
Okay. Let's see what it does. I don't know. Basic make. Okay. Conversion to non-scalar type requested. So let's see if that's your off. If that's your off T here.
Yeah. Sorry. I think there are two. It's.
Size T.
I don't. No. It's. I think maybe it's. I'm not. There are two types. One is the C type and one is the POSIX type.
Oh, actually, it was a different error. Yeah, it was not that one.
Okay.
So let's just find out if we can maybe get the of T further up, if it compiles, at least partially. Sorry, let's just remove the STL. It's a bit too much to read, and I'm getting confused. So, right, that's the basic one. Get of T, make. Okay, and let's just say 3.
It's now size T.
7.
It's now size T in this.
Yeah, don't worry.
Okay. Okay.
Size T of T, like that?
Yeah.
Okay, make. 3. I just thought I already removed it. 397. Oh, of course. It was the vectors. Well, let's just comment out the rest. I don't want to deal with this right now. Make. Yeah, now it works. And let's see what it actually did. I don't know. Load file. And it's here. Read.
Share your video again.
I want to do what?
Share the video.
Oh, thank you so much for pointing that out. Should work now? No? Press it harder. Now it works. So the get. So get of T is an of T result, and it pushes a single. I cannot give you the details on why it decided to do that, but that's what it did right here.
64-bit value.
I guess in that case, yes.
So how would I change that?
It's why would you change that in the system? It's how C does it. C gives so Swig says it's a 64-bit value. It fits into a cell. So my system says it fits into a cell, and then it pushes it.
Yeah, but I want to call it from portable fourth code.
then you should write a wrapper for the wrapper,
Okay.
I think.
And
So
how do I, as a on the fourth side, know that it returns a single size integer?
You would have to look at the documentation, of course. I mean, you can do some things, right? I'm not showing you all the stuff because if you look at Bernd's interface files, you can imagine that they are not so basic. And depending on what you want to compile. So, for example, I think there is something like %type, and then you can say of t is something else. I don't know, long, yes? And then then this version would treat it as a long, and do all the magic around that. That's a but it's not like that, okay? This is just approximately how it could work. Does that answer your question?
Yes.
Okay. Right. So I think we still have a bit of time. Should we take a quick look at Anton? Are you correct? Is it correct or?
4 minutes.
Right. So are there any questions or? Good. Then I'll just gonna show you real quickly. We're just gonna look at the header because we don't have so much time. GTK4, GTK, and GTKH. So if we look at GTKH, it does the same that SDL does. So we now know we need to include everything manually. And if we now go to GTK and then GTK about dialog, so it looks sane now, but so one of the things it does is, for example, it wants to have GTKH inside defined, otherwise it would bail out. And then it has these stupid things like begin decals, end decals, and it has, so you would have to, again, you just define them because they don't do anything, but you also have something called G type, I think, well, not in this. You have something called G type. It's not in every header, but it's in some. And I haven't found out what it is. So then you would have to search through the library and find out what that actually is and define it yourself, for example. Or, or just find a way around it. But essentially, I would say complicated libraries like GTK might require an expert to translate them, but it should not. I think you can all do it maybe in more time than I, but you will still be able to do it. I want to take the fear away from you, okay? So, yeah. Okay, so that's it. I would say thanks for your attention. If there's any more questions, please go ahead.
You were going to show us a window. You did?
I did.
Oh, right.
You.
The quickness of the end deceives the eye.
Exactly.
It was not very spectacular, but
There you go. There's the window.
Thank you. Yes,
Okay.
you did. You did. I apologise.